Okay, so the next important thing is a method called factors of change. And factors of change really centers around the multiple choice questions. So these are type questions, and not to say that it's not also a free response question, but this is oftentimes when they'll ask you, like, what happens to the force if you double the mass? What happens to the speed if if there's 5 times as much kinetic energy in there? Okay, but remember, factors means multiply, right? And that just means how many times bigger or how many times smaller than something is. Okay, so it's, like I said, it's mostly used in multiple choice questions. And then here's the method. So what you're going to do is you're going to plug in ones, like the number 1, for values that will remain constant. So if they don't change, plug in a 1 for that value. Then you're going to plug in the factors of change for anything that changes. Okay, so what this means is how many times greater or smaller. So if I double the force for F, I'm going to plug in a 2. Okay, and then you're going to determine the factor of change for what you're looking for. Okay, and this is a little bit of algebraic solving. Okay, so if I have F equals ma, and I'm doubling the force and I'm keeping mass constant, what happens to my acceleration? Well, I need to solve for a, okay, to determine what to determine what happens to my acceleration. So in that case, if I doubled my force, that means I had my acceleration. Now, here's one where it really shows up, is when you talk about the gravitational field. Now, if you're at a point in your class where you've never seen the equation, okay, but this is Newton's law of universal gravitation. So this basically says the lowercase g value is constant, okay, near the surface of the Earth. And this is just to show you through the factors of change method how that is true. So Miami, which is approximately sea level, versus Denver, which is approximately a mile high. Okay, they tout it as a mile high city. Okay, so what we need to do is find what factor, right, did we change d by. And so what we need to do is, if we're comparing Denver to Miami, we're going to put Denver up top, and then we're going to put Miami on the bottom. Okay, so we're not subtracting these, right? That's not a factor. We're looking for the factor of change, and so Denver is 1.0025 times greater than location than Miami. Okay, and so now I can go in and plug in my values. Okay, so what I'm going to do is we're going to do a little bit of preview of upcoming chapters. So I'm going to plug in the weight, okay, equation, and I'm going to cancel one of those out. And I'm looking for the factor of change for this, okay? And so what does that mean? I'm going to say G equals, now this is a constant, so that's not going to change. I'm going to plug in a 1. M2 actually works out to be the mass of the Earth. That doesn't change. If that changes, we have a very big problem in our universe. Okay. Now, what changed? The distance, right? So I'm going from Miami to Denver. So I'm looking for that factor of change, and that's what we determined over here is 1.0025. Now, in the equation, it's squared, so we need to square it when we're looking for our factor of change. And so essentially what we're going to do is 1 divided by 1.0025 squared, and find that the difference between Miami, right, and Denver is 0.9995. Okay, what does that mean? That means it's roughly 99.95%, right, different. Okay, now, is that a big change? I mean, that's a 0.005% change. That's not going to be, that tells us right there that it's constant. But you can see through this method of factors of change, right, we determined that G is constant here on Earth.